Right, so let's talk about partitioning line segments. When we talk about partitioning line segments, what we mean is we're going to find some coordinate along this line that splits this segment into a specific ratio. So if we look at our example problem here, it says find the point Z that partitions the segment AB, what we have sketched here, in a 2-to-1 ratio, where A is down here at -8, -2, and B is up here at 2, 6. So this 2-to-1 ratio is telling me that it needs to be 2 parts to 1 part, which means there's really a total of 3 parts. And I can kind of estimate that out here, just very estimating right here, maybe right here and right here, splitting this into thirds. So a ratio of 2 to 1. So it's really asking me, what is the coordinate point kind of right here? What is the very specific coordinate point that does this perfectly? It doesn't just estimate it. There are many different methods on how we can go about trying to find this, but the method that I like to do is kind of a process of thinking about what are we really doing here? So in a unit where you might be doing this, more often than not, you're also finding slope and distance. And so you've already found your delta x and your delta y. So your total change in your x direction and the total change in your y direction. So that's where we're going to start here. Algebraically, our delta is just subtracting the two. So I'm going to do 2 minus -8, which gives me 10. And in the y's, I'm going to do 6 minus -2, which gives me 8. What that is really telling me here is that in the x direction, I went over a total of 10 spaces. And in the y direction, I went up a total of 8 spaces. That is my total change to go from A to B. But I don't want to go the entire way. I want to go 2/3 of the way. My ratio tells me that I really just want to go 2 of the 3 total parts that I can go. So we know that if we want to find a portion of a whole, we just multiply those. So what I really want, I'm going to call this delta x of the partition. How much I actually want is just the total times that fractional amount. How much do I really want? Which here is going to be 20/3. In the y direction, I'm going to take that total amount again, which was 8. I'm going to multiply it by how much of that total I want, which is 2/3. And that gives me 16/3. So this, what we've just done right here, is how far we need to travel. So if I were to come back from A and try to get to this point, I need to go to the right 20/3 and up 16/3. So we can actually estimate that out and see if it works really quickly. I know that 20/3 is the same thing as 6 and 2/3. I know that 16/3 is the same thing as 5 and 1/3. So that's going to help me as I try to estimate it out. So from point A, this is how far I actually want to go. So I'm going to go to the left 6, 1, 2, 3, 4, 5, 6, and 2/3. So kind of right here. And then I'm going to go up 5 and 1/3. So I'm going to go up 1, 2, 3, 4, 5, and a third. And what do you notice? I'm kind of at that partition I already found. So I know that my estimating here was actually pretty point on. That is the coordinate point that I want. The problem is I still don't know the value of that coordinate point. I know how to get there. I can do in confidence that I've done 2/3 of my total distance, but I still don't know the value of that point. So the best way that we can define the value is to do what we just did, but instead of counting it out, we're actually going to add it to that original point. So the very last thing I'm going to do is I'm going to go back to my original point of A, because that's where I'm starting. And I'm going to actually physically we did on the graph, I'm going to mathematically add my changes. So delta x was plus 20/3. Delta y was plus 16/3. And I need to actually just add these together to get the value of that point. Now, whether or not you have access to a calculator might affect how you do this. I don't have one with me right now, so I'm going to go ahead. I know in order to add a fraction, I need that common denominator. So I'm going to rewrite -8 as -24/3, and -2 as -6/3. And I'm going to move these over, going to move my change over so they're still lined up for me. And now I can go ahead and add negative 24 and 20 is negative 4 over that common denominator of 3. And negative 6 and 16 is 10 over that denominator of 3. So my original point plus the actual change, the distance I want to go, gives me my final point. So this right here should be my final point. Let's try it and see if it works. So we said the coordinate point that we came up with for z was equal to negative 4/3, 10/3. Negative 4/3 is really negative 1 and a third. 3/3 is, or 3, wow, 10/3 is really 3 and a third. So let's see if that works. Now I'm starting from the origin. This coordinate point that we found is actually a point from the origin. So I'm going to go to the left 1 and a third, and notice I am lined up. And then I'm going to go up 1, 2, 3, and a little bit more, and it all lines up. So there you have it. That is how we can find a coordinate point that partitions. Find your total change, multiply by how much that you want, and then go ahead and add that back to that original point, and it's going to give you your final point.